Okay, so chapter 4, section 2 is about applying congruence and triangles. We're going to talk about things that are congruent, not just lines that are congruent, not just angles that are congruent, but whole shapes that are congruent. This actually happens a lot in the real world. Like if you think about it, if you go, like let's say it's Christmas time and all the kids are excited for like what they're going to get for Christmas, and you go to the toy store and like, you know, your little kid wants, I don't know, whatever the new toy is. Let's say it's it's a Hot Wheels car, and they pull it off of the shelf there, and right behind it is another one exactly like it. The only way that like these toys that people want them is because they look exactly the same. They are manufactured to be the exact same shape, exact same size. And that's what we talk about in congruence, is that like we have lines that are the same shape, same size, angles that are the same shape, same size. But when you put it all together, you get whole shapes that are the same shape and same size. So we're going to talk about that congruence today, and how do you identify when an entire shape is congruent, and especially in triangles, but we're going to talk about some other shapes. Okay, so when we are talking about congruent figures, meaning any sort of shape that is congruent, any sort of like triangle, quadrilateral, a pentagon, they are, two figures that have the exact same size and the exact same shape. So exact same size and exact same shape. Is it possible that a right triangle and an equilateral triangle could be congruent?
No.
Why not?
Because the right triangle has...
Because all the sides on the equilateral have to be 60.
All the angles on it. So if you think about how an equilateral triangle would look like, it would have these equal sides, equal angles, would look something like this. And a right triangle, now right triangles can look all sorts of different, but it's generally that we're going to get this like sharp edge there where we have our 90 degree. So now looking at them, I mean, it should be obvious that they're not the same shape. Even if I made them the exact same size, if they had the same area or something like that, they're not the same shape. So this is the most important thing that we're going to talk about today, is this next line. All of the corresponding parts of one figure must be congruent to the corresponding parts of the other figure. And what we mean by that is that for, for two shapes to be congruent, it means each and every one of their parts is congruent. I'm going to zoom in a little bit here. Let's see if I can get that. So if you notice angle A and angle F, they are both congruent to each other. That is one of the three angles that are congruent. If you look at angle B and angle E, they are both congruent to each other. That's two out of the three angles that are congruent. If you look at C and D, that's the third angle that is needed to be congruent. All three angles of one are congruent with three angles from the other. But in addition to that, not just the angles, the sides must also be congruent. So we've got AB is congruent to FE. We've got AC is congruent to FD. And then finally, we've got BC is congruent to ED. Basically, what we're saying is that if I'm going to say these two things are congruent, I need to prove to you that every single angle is the same and every single side is the same. I can't just say, well, the three angles are the same. I could make an equilateral triangle that is the size of this room, or I could make an equilateral triangle that is the size of something that fits on my fingernail. Either way, they'd still be equilateral triangles, but if I don't prove that they're the same size, I can't say that they are congruent. So it's not just angles, it's not just sides, it's the sides and the angles are all congruent to each other. Here is what somebody stumbled across yesterday, and I want to address it today because this is a really important thing, is that we said if two angles of one triangle, by the way, this is called the third angles theorem. This is really important. We're even going to use this in a proof today. Hint, hint, wink, wink, nudge, nudge. That is a very important thing that we're going to use today. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. What they mean is this, is if you look at this top angle, this one is congruent to that one. And the second one is congruent to this one with two lines. But there's nothing for that last one there. And they're making the statement that these two must be congruent. But let me prove to you why that has to be true. Let's look at triangle ABC for a minute, for just a moment, and let's make up some numbers. I don't care what numbers we make up, but let's say that either angle B is either a right angle or it's an obtuse angle, right? Because it doesn't really look acute. Let's just make up some numbers just to pretend for a minute. So somebody give me a number for B. Like somebody either be right or be obtuse, one of the two. Well, B, angle B there, it's definitely gonna be more than that's. I'm trying to get a number that actually look. This one right up here, which kind of looks either maybe it's obtuse or maybe it's right. Colette, give me a number. Let's call that 90. If that's 90, won't this be 90 as well? Okay. Let's look at that one in the lower left, and I'm going to go with your suggestion of 60 and call this one 60 down here, okay? I'm just playing a what-if game. Well, if that's 60, then this one must be 60 as well. Well, let's finish up this triangle right here. If I take 90 and 60 and add them together, what do I get? So what is the remaining angle in there? It has to be 30 degrees. Okay, well, let me go over to this totally different triangle over here that has angles of 90 and 60. When I add 90 and 60 together, I get 150. And if I take 150 away from 180, what do I get? 30. They had to be the same. If these two angles were the same, it just means I'm going to add them together and take it away from 180. And if these are the exact same angles, then I'm going to do the exact same thing again. So it means if you have two angles of one triangle that are congruent to two angles of another triangle, then the third angle has to be congruent to each other. There's no way that they couldn't be. Now, it does not mean that these triangles are congruent. It means that the angles are congruent.
If they gave you none of the numbers, then it wouldn't apply.
It does apply. I'm just showing you that this was my point, was that I was trying to prove it to you. Because sometimes, you know what I think what happens in math classes is people just ask you to believe things. They just say, oh, that's just the way it is. I'm not really big on that. Like, I don't really just say, like, I'm not big on just saying just believe it. Like, I wanted to show you that it's true. Of course it's true. If we, like it doesn't matter what numbers we picked. We could pick any numbers in the world for A and B. It would have worked out the same way that the two triangles would have ended up the exact same, no matter what, because they already showed us that these angles are congruent. Notice that A and D are congruent, B and E are congruent, and we didn't know about C and F, but if two angles...
Angles are congruent, wouldn't that make the triangle congruent also, because they have the same...
This is a great question, and I'm glad you asked. So she's saying, but wait, doesn't that mean that if the angles are congruent, that wouldn't the triangles be congruent? So I'm going to try to illustrate that point why it's a great thought, it's not actually true. So you're gonna have to believe me on certain things here because we're not gonna sit here and measure. I'm gonna try to prove to you that, okay, so I have 3 pens. They're all the exact same type of pens. I'm not trying to trick you. You can see like there's different colors of the exact same pen. I bought them from the exact same pack. So you can believe me that they're all the same length. They came from the same thing. The only difference between them is the color. So if I were to put them together and make a triangle out of them, they are equilateral triangles. Do we agree about that? Like all the sides are the same. I'm not trying to trick you on that. So what is true about the angles here? The angles are the same. And what is the number of that? What does each angle measure? 60 degrees. Okay, keep that in mind that this is an equilateral triangle and it's got all the angles are 60 degrees. I'm going to put that aside a minute. Three toothpicks. All the same size. All of them are exactly the same. But we agree that they are not the same size as the pen, right? The pen is much bigger than the toothpick. I'm going to take these 3 toothpicks and put them together. I now have an equilateral triangle. It is a very tiny equilateral triangle, but I have one. And if it's an equilateral triangle, what is true about the angles? It's equal angular, so what is the measure of each angle? So I can't hold up both at the same time because I was not graced with enough arms in life, but I go, right here I've got an equilateral triangle that has all the angles that are 60 degrees, which is way smaller than this one made out of pens that also has 60 degrees, but the sides are longer. So the angles aren't enough to say that it's congruent. So having 3 angles that are congruent, there is another term for that, which we will get into, but having just the angles being congruent is not enough. Angles and sides would need to be congruent. Okay, so here's where we get into our properties of congruent triangles. And these are actually theorems that have not changed. We're just talking about triangles now instead of lines or instead of angles. Okay, first comes up that reflexive property of congruent triangles. Remember that reflexive property was like something looking in the mirror. Like, so if you see that one side right there is exactly the same as the other. And we use this at one point to show that like a triangle is congruent to itself, or a line is congruent to itself, or an angle is congruent to itself, which seems very silly, but actually ends up being one of the key pieces to a lot of our proofs sometimes, is being able to say that something is congruent to itself. We've got the symmetric property of congruent triangles. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to ABC. If my money is congruent to your money, then your money is congruent to my money. Please be careful that, notice that triangle symbol in the beginning. Here's what happens every time around this part. It's new, writing a triangle in front. People use an angle sign instead. This is angle ABC. In the diagram, it would be right here. This is triangle ABC. In the diagram, it would be right here. The difference between those two things is one is a triangle, one is an angle. Finally is the transitive property of congruent triangles. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to JKL, triangle JKL, then the first one must also be congruent to the last one. Triangle ABC is congruent to triangle JKL. If the first one is congruent to the second one, and the second one is congruent to the third one. Sorry, if the first is congruent to the second and the second is congruent to the third, then it must mean that the first is also congruent to the third. Those must be congruent to each other as well, because they're all equal to each other, all the same shape, all the same size. Yes, ma'am?
What if I meant to ask this on the last slide, but what if the angles were switched around?
Okay, so great question. What if the angles are switched around? For example, let's say, I'm going to come up here for a minute. This is a great question. Let's say I've got this. And let me draw this another way. Are these triangles congruent? Yes, no? So what is the requirement to be for two triangles to be congruent? What has to be true?
Same shape and size.
Same shape and size, but how do we verify that? Like, other than being like, well, they look the same. There was a slide a few things back. What has to be true?
They have to be, they have to have the same, like, size
And?
and angles.
Sides and angles. Do they have the same sides and angles? Yes. So think about this. Let's say that I go to the store and there's two, like, I don't know, Toy Story Woody dolls, right? I'm going to like get my little niece something and I have 2-story Woody dolls and I go like, oh, here's two. And I drop one to the floor. It doesn't break or anything like that. It just fell and it landed in a different position. Are they still congruent to each other? So their positioning doesn't matter. As long as the angles are the same and as long as the sides are the same, that's all we need. So the position of them doesn't matter at all. Like, they could be turned different ways, they could be flipped over, still the same thing, as long as the angles are the same and the sides are the same. All right, let's play some always, sometimes, never. Always, sometimes, never. All right. An acute triangle is always, sometimes, or never congruent to an obtuse triangle. Never. And our justification is that they're not the same shape. If you think about it, it's the angles that make the shape. Like, the angles are what define it as like what it looks like. The sides define the size of it, how big it is. Like, think about it. Like, the Statue of Liberty, if you went there, is like a really big statue, right? But you could go probably to the gift shop. Like, don't get me wrong, I haven't been to the Statue of Liberty since I was a kid, so I don't know, maybe there's not a gift shop outside. But if there's a gift shop outside, you could probably buy a little model of the Statue of Liberty that is the exact same shape, but it's not the same size. So the sides really define the size, and the angles define the shape. A polygon is always, sometimes, or never congruent to itself. Always. Congruent to itself, for sure, it's always. Just like I am congruent to me, you are congruent to you. Something congruent to itself will always be true. A right triangle is always, sometimes, or never congruent to another right triangle. I heard always and sometimes. So let's think about this. Let's answer this question. We've got a right triangle. I'm going to do two right triangles, and you're going to tell me whether they're congruent or not. Actually, I'm going to draw that a little differently. do this. 45 and 45. And then I'm going to draw another. Two triangles, both right triangles, both have the angles of 45, 45, and 90. Are they congruent to each other?
No.
Definitely not, because they don't have the same size. So while it is possible, it is not always true. So we will say this is sometimes. Yes, ma'am?
With the right triangles, do the other two angles have to be 45, or could it be like, I don't know?
No, we just did another one on the other side that was 30 and 60. Remember?
Yeah, that's what I was thinking.
So right triangles can be other two. There's just one thing that I always know about these two angles that will always be true. What did we learn yesterday will always be true about those angles?
They're both gonna have a 90.
They're both going to add up to 90. They'll be complementary every single time because we already know that 90 of it is accounted for right there. So the other 90 needs to be accounted for right there.
Okay, so Chris, when my brain first went to when it asked if it was congruent, I was thinking the angles would have different measurements, not the sides, but basically it can be both, right?
Right. So the reason I do it this way is because I go, this is a little more confusing, is that people are like, wait, but they are the same shape. Yeah, they are the same shape, but they're not the same size. Okay, if triangle ABC is congruent to triangle XYZ, then angle A is congruent to angle Y. This is my bad. I didn't talk about this on the slide. I really should have. So let me just address this right now. When we say triangle ABC is congruent to triangle XYZ, not only does it mean that the triangles are congruent, it means also this. Here, this is really important, and I should have addressed this on an earlier slide. I'll address it right here. It means that angle A is congruent to angle X. They have the same position. They're in that first position there. It means that angle B is congruent to angle Y. They're in that second position. Those are the two angles that are definitely congruent to each other. And angle C is definitely congruent to angle Z because they are in the same position. So those are the angles that have to be congruent to each other. Hang on. Additionally, it also talks about the sides. Side AB, notice I'm putting a line over A and B, will definitely be congruent to side XY. Side BC over on the left will definitely be congruent to side YZ because notice they're in that same position when we write the statement. And then finally, the only other side there is AC. Line AC is congruent to line XZ. So knowing that, it says if triangle ABC is congruent to triangle XYZ, remember, if they're congruent, that means their sides and their angles are they're all congruent to each other, then angle A is congruent to angle Y. Never. What is it congruent to? To X. So again, the first angle over here is congruent to the first angle over here. The second angle congruent to the second angle, the third angle to the third angle. They are written in such a way that it shows which angles are congruent to which angles, and you will have to write them in that same manner. Yes, ma'am?
Even if the angles just switched, it'd be the same thing.
Even if like I switch sides?
Yeah.
Yeah, so check it out. Let's write it the other way. Triangle XYZ is congruent to triangle A. Oh, sorry.
No, I mean if they would switch the order.
Oh, sure. So watch this. I'm going to just write this backwards, okay? I'm just going to call it triangle CBA. Triangle CBA is congruent to, well, then I got to write the other one backwards too. ZYX. Triangle ZYX. The way that I write the first one determines what I have to write for the second one because the angles have to match up. And notice when I wrote it backwards, C matches up with Z. Let me just make sure that was true. Look, it matches. B is congruent to Y. Notice that matches in this one too. And A is congruent to Z. Notice that matches as well. I'm sorry, A is congruent to X. Sorry, I said Z. Okay, using that, if triangle ABC is congruent to triangle XYZ, then triangle A is congruent to, angle A is congruent to angle X. Always. Because we have to write them in such a way that it shows the congruent angles and the congruent sides. Yes, sir.
I was going to ask something about number 4.
Okay.
If both triangles were equilateral, wouldn't it be sometimes then? Because it would still be congruent?
If triangle ABC is congruent, then triangle A is, oh, bravo. Good point. I hadn't even considered that. You're right, that would be sometimes. Thank you.
Wait, why?
Here, check it out. Here's what he said. Okay, he's got a very valid point here. He's got triangle ABC. And he's saying, well, what if the situation where it's an equilateral triangle, 60, 60, and 60, and it's congruent to, what was the other letters? XYZ? Triangle XYZ, which is also a equilateral triangle, 60, 60, and 60. Now look, every angle on the left is congruent to every angle on the right. Like, look, this one here, this one here is congruent to every single one on the right. Like, it's congruent to every single one there. Why? Because they're equilateral. Good call. Thank you for noticing that. I need more coffee. Yes, sir.
Congruent means the same size, same shape.
Right. So they both have the same shape because of the angles, and we learned that every single equilateral triangle is also, every single equiangular triangle is also equilateral, so they would definitely have the same shape. All right, here's where we get to some fun stuff. Now, these are not triangles, so don't do this. Do not tell me that they add up to 180. Don't do that. That's only in triangles. That's not every figure in the world, only triangles. In the diagram, quadrilateral, it's 4 letters, so I call it quadrilateral ABCD is congruent to quadrilateral FGHK. Even if it's not a triangle, it still indicates which angles are congruent to each other and which sides. For example, angle A is congruent to angle F, angle B is congruent to angle G, angle C to angle H, angle D to angle K. So it shows them, and you could even do it with the sides, like side AB is congruent to side FG, and side BC is congruent to side GH, and side CD is congruent to side HK. So if you're not sure, if you're looking at the shapes and you're like, I'm not really sure what matches with what, then come back to the congruency statement because it's your little cheat sheet. All right, let's talk about this one, and let's find the value of x. Somebody hook me up. Yes, ma'am.
Okay, so if they're congruent, that means that their sides are congruent.
Okay.
So that would mean that 3x minus 6 is equal to 9.
How did you know that this was the side that was congruent to this side? Like, I get it that they look like they're the same shape, like, but how do you know that those are the ones I'm supposed to match up with each other?
Because they're corresponding.
Okay, so, but like, how did you know they were corresponding? What gives it away? You're 100% right. I want you to like take a little further. How can you guarantee me that you're making the statement that GF, line segment GF, is congruent to line segment BA? How did you get that other than just by looking at it?
Because of the position, like in terms of when they wrote A, B, C, D is congruent to F, G, H, K.
Okay, back here at the top, our congruency statement. So notice here that AB was congruent to FG, and that's exactly what we did. We saw that AB is on the left, FG is on the right. Okay, so good. Now I'm going to go with that now. 3x minus 6 is equal to 9. Bless you. Add 6, and we get 3x is equal to 15, and x is equal to 5. Okay, somebody different. Talk to me about finding the value of y. Yes, sir.
So you get, it says k is 4x plus 2y. So 4x plus 2y is equal to 44. Because k is
Congruent.
x is 5, so it's 20 plus 2y equals 44. And subtract 20 from those sides. And then you divide by 2.
So his question is, after the 12, does that get degrees? No, it doesn't get degrees, because notice that the angle, to figure out what this angle is, however many degrees, you need to plug in x, you need to plug in y, and multiply it by 4, then multiply it by 2, add them together, and whatever you get as the number at the end, that will get the degrees. And even here on the other one, the x would definitely not get it because it's not even an angle. It's a side. It's like the length of it. So even if like we'd plug in x and whatever we got left, that wouldn't even have degrees because that's in inches. What's that? We wouldn't put inches on the x either because it's not x inches. It's whatever x is, multiply it all out, and then whatever that answer is in inches.
So let's say on the test we like put in x and we put the degree sign, would you mark it wrong?
Well, yes, because it shows me that you think that's an angle, and that would be a gross misunderstanding of it. All right, so we got to use a little bit of thought on this one. Maggie took the piece of fabric STUV. There's this quadrilateral, STUV, shown in the diagram, and cut it on the diagonal to make a scarf for her and a friend. So basically what she's doing, she's slicing from the upper left to the lower right, and she's cutting it into two triangles, more like bandanas, for her and a friend. Are these two pieces the same size and same shape? If you're going to say yes or you're going to say no, you've got to be willing to back it up. So let's be willing to back it up and talk about why this is true. Because if these two triangles are the same shape and same size, here's what I'm going to ask you to do. Prove to me that every single angle in one of the bandanas is congruent to every single angle in the other bandana, and that every single side on one bandana, whatever you want to call it, is congruent to every single side on the other bandana. So if you're not ready to do that, then you may want to hold off on throwing your hand up. But if you know part of it and you're willing to contribute part of it, I'm okay with that too. All right?
Okay, so first of all, I know the sides are congruent because of the lines that tell me they are.
Okay, let's actually just mark that. Let's just show what she's talking about there. I can see that SV is congruent to UT. You'll understand why I wrote it like that. Some people are probably asking, why did I do it like this in this direction and then this in this direction? Don't worry, you'll understand later. We'll get there. Okay, so that's true. And I can see that ST, the top line, let me switch colors here so I can color code this. ST is congruent to UV, so ST is congruent to UV. That's two sets of the lines. I thought you said all three sets of the lines were congruent to each other. You're not wrong. You're not wrong. Just fight for it.
Well,
Here's the third line.
I mean, it's in the same, it's in a rectangle, so like they have to be, they share the line. So they're
Okay.
congruent.
Okay, so she's saying that line is shared. We have a name for that when that happens.
The third side theorem. Right?
Not third side. We don't have a third side theorem. That would be cool if it existed, but actually it actually never exists. The third side theorem. But there is a theorem that says, and it's the same one that I talked about when I said the reason that I'm not allowed to bang on this wall right here. I'll go to that wall across there and bang on it as much as I want, but out of respect, I don't bang on this wall.
Adjacent angles,
It's what?
adjacent angles.
It's not about the angles.
Adjacent lines.
Not adjacent. What? Not adjacent lines.
It's adjacent though, right?
Nope.
Linear pair.
Not a linear pair.
Isn't that a linear pair that they share the same wall? Or reflective? Oh, that's.
Ah, the reflexive property. So remember that apartment? Look, like here's me in my classroom. Here's Mrs. Corey in her classroom. The reason I won't bang on this wall is because that is her wall as well. So saying that this wall is congruent to this wall is not a problem. I can say that SU is congruent to SU. So these were given, right? That was given to us. Just in case we had to do this as a proof. Given. And this was the reflexive property.
But isn't that also the same thing?
No, linear pairs are two angles that add up to equal 180 degrees. They have opposite rays and a adjacent side. They have a common side where the two angles are adjacent. Okay, so we've proven now that that all the sides are the same. But I told you that I need for you to prove that all the sides are the same and all the angles are the same. Yes, ma'am?
You know all the angles are the same because all of them have like V and T both are 90 degrees.
Okay, so I don't disagree with you at that part at all. V is congruent to T, no doubt. That's given that they are 90 degrees. Really, if we had to do that in a proof, we would say V is equal to 90 degrees, given. T is equal to 90 degrees, given. These are equal to each other because of the reflexive property. But whatever, it's not really set up as a proof, so we're just kind of improvising here. But what about the others?
Well, they're split, but
They're split in a weird way.
They are split in a weird way. They don't even look even. It doesn't look like it was split right down the middle.
but you can tell that like the two triangles are, it's like they're flipped. I don't know how to explain it.
Okay.
Like,
I mean, that's not going to work in a proof, but it's good thought process to get us going forward. Let's talk about this. Here's what's going to solve it for a lot of people. You think you got something?
Well, it says it's cut on the diagonals.
Okay.
I kind of thought that would be like in and out.
Well, so if it were a square, it would be perfectly, like, cut that angle perfectly. But you can see that that angle is not cut perfectly. It's not 45 and 45. Let's talk about this. Forget about the triangles for a minute. In general, the fabric that she started with was what kind of shape? Okay, so one thing we know about rectangles is that the top and bottom are congruent, the left and the right are congruent, but we also know something else about the top and bottom, and something else about the left and the right.
They have the same, like, not inches, but like, they have the same side length.
That means congruent, yeah, same length. They are parallel. So let's see where that takes us. This is congruent, is parallel to that, and this is parallel to that. Let's go on that idea. I'm going to erase these people here because I don't think we really need them in our apartment anymore. Go away. I'm a man of God. Ah. All right. Yes, ma'am.
Because they're parallel, you can tell the angle 1 and angle 4. Oh, wait. They're opposite interior angles.
They are alternate interior angles. So tell me, you bring the two things that you were just saying together into one statement, though.
And since they're alternate interior angles.
Which ones are alternate interior?
1 and 4.
1 and 4 are congruent because they're alternate interior angles. So check it out. If you can't see it, notice here I've got a parallel line, and a transversal that comes across it. So 1 and 4 are parallel. Are congruent. What about the other ones, though? Because that proves to me I'm okay with that. I'm like that. So angle 1, ooh, that's a highlighter. Angle 1 is congruent to angle 4 because of alternate interior angles. Only because they're parallel. That's because we like this. They would have to tell us it's a rectangle. I'm just trying to show you how we can get there. What's the other set? Like, how do we do the other set? Colette? Angle 2 and angle 3 are also alternate interior angles, but they use different lines. Watch this. There, you got to do this. So here is a line, the bottom one and the top one, and here is their transversal. Now, some people go, how did you know to use those lines? Because if you look at angle 2, it uses these two lines. And if you look at angle 3, it uses these two lines to make it. Those are the sides of that angle. That's how I knew those were the lines that I would be looking at to see if they are parallel. So the top and the bottom are parallel. So 2 and 3 are, in fact, congruent. So angle 2 is congruent to angle 3, and that's because of alternate interior angles. So I'm going to go ahead and I'm going to make a congruency statement. I'm going to say that triangle blah, blah, blah is congruent to triangle blah, blah, blah. This was not a proof, but I just got kind of excited there. Now here's the hard part, but I'm going to make it really easy if you pay attention to this. I'm going to make it really easy. I need to make my statement so it matches up every single angle that matches with every single angle. So I'm going to focus on one of the two triangles. Just because I see it here, I'm going to focus on this triangle first. Now? Yeah. Okay, just understand you have to watch the video for the lesson. Okay, I'm focusing on this bottom triangle here. I'm just looking at that for a moment. And I'm going to name this bottom triangle. And I don't care what you name it. Any 3 letters that you want. I can call it triangle SVU, USV, SUV, whatever you want. Somebody give me a 3-letter combination. Yes, ma'am. SVU. So I'm going to write that triangle SVU is congruent to another triangle. But I have to be very careful. Because when I do this, I have to make sure that the congruent angles are matching up. So SVU is congruent to, so look at S. Angle S is congruent to which angle on the other triangle? Angle U. So this one has to go first. Notice that this one had one line and this one had a one line. Then you told me V. V was this 90-degree one there. It matches up with what? T. And then finally, the only thing left is UTS. So if that statement were written incorrectly, it is incorrect. You can't say them in a different order and expect to get it right. And why are they? Well, now, why are they congruent? Because we said all three sides are congruent, all three angles are congruent. This is the definition of triangle congruence. Three sides, three angles congruent. Yes, ma'am.
Wouldn't it not matter the order we put it in because since they're congruent, they have the same side and same length?
No, because just because something has three angles that are the same, it doesn't mean like look, 1 and 4 are the same, not 1 and 2. So I can't match it. Yes, they have the same angles, but it's like saying, can I swap your arms out with your legs because like they're like people have arms and legs, so why can I swap your arms and legs out? That doesn't work.
They don't have the same side length either.
They not every look, the bottom is the same as the top. So ST needs to match up with VU. ST VU. They match up there. If we didn't do it that way, like so the same congruent sides and congruent angles match up, it wouldn't work. Yes, ma'am.
Could we have written it as TU?
As TU? Well, then if you wrote it as TU, then you had written it as VS. This is the only once we decided this, it was a guarantee what the second part is. Like it is a guarantee because the angles had to match. This angle right here, had to match up with U, this one right here, because those two match up. That had to be first and first. Once she decided this, now the first one we could have said whatever we wanted. But once we did that, we set up a pattern to be like, okay, we have to follow that now. We got to follow through with what we said we were going to do. All right. If I were you, I would clear off some space over here, like make yourself some room, like, you have another page that I don't have?
No, just saying like an empty page.
Oh, okay. Okay, whatever you want. Okay, so we've got our statements, we've got our reasons. Be very careful because some people on the test wrote their reasons on the left and their statements on the right. I gave them 0 points for that because that's completely off. They had everything correct, but in the reverse order, and I go, that is not correct at all, not even close. Okay, so here's what I'm going to do is I'm going to write the given because I know that's like free points, right? Like let's just get the free points. So SV is congruent to RV. All is one line here. There's no point in putting it as more lines. You don't get extra points for doing it in more lines. And then, where am I at? ST is congruent to RW. And then finally, T is congruent to angle W. That's a lot of information right there. So much information that I don't know that I could process it all right there. So what I'm going to do is mark those things that they said. I'm going to take those things that they said and mark them in my picture. SV is congruent to RV. SV is congruent to RV. Notice I just marked what they told me. TV is congruent to WV. TV right there, congruent to WV right there. ST is congruent to RW. ST, RW. Finally, angle T is congruent to angle W. Angle T up here is congruent to angle W right there. All right, you guys are up. That's it. That's where I stop. I don't know how to do proofs. I've been faking it this long, and you guys figured them out, so maybe you guys can teach them to me. Let's go. Anything at all. You don't have to take me all the way through. What do you know about these shapes? Yes, ma'am.
This side. I was gonna say they have equilateral sides, but like that's not really what I'm trying to say. I'm just like.
Yeah, I can't say that the sides are equilateral because it doesn't say that like one triangle, all the sides are the same as itself. It just said each side on one triangle matches up with the side on the other triangle.
I don't know if this is right, but ST is parallel to WR.
So why?
Because they're congruent.
So if you're gonna, she's not wrong when she's saying this, but I'm gonna ask her to back it up. She's making this statement: ST is congruent. By the way, I would not go this way. I think you're going the longest possible way. However, it's not incorrect. This will get us there. You're not incorrect. They are parallel. I know that, but you have to come up with why. So tell me why. Why are they parallel? How do you know?
Because they have the same
Sorry, we're going off that one. Good. You weren't wrong. You had the wrong reason. But I'm telling you right now, let's not go down the parallel route. There's a much easier way. Yes, sir. Why? Only if they're parallel. So prove they're parallel, and then you could do that. We'd have to prove they were parallel. By the way, we're not wrong about parallel. However, we don't need that. Like it's easier than that. Everybody's kind of focusing on the wrong angles right now.
Is S congruent to R because S is congruent to R and B?
No. I mean, those angles are going to end up being congruent, but not because of that reason. So everybody's focusing on S and R right now when you're missing the obvious one.
W and T are congruent.
They already gave that one to us. That was given.
V is equal
There's no such thing as angle V. No such thing. It doesn't exist. Because is that here? Is that here? Is that here? Is that here? I don't know. None of that makes any sense. I'm being hard on you because I want you to tell me if you want to talk about this area, you better be real specific about what it's called. Because that's real confusing area.
Oh, is there any way that we can say that they're alternate exterior sides?
No, trust me. By the way, you're gonna kick yourself when you hear which one it is.
Angle WVR is congruent to angle SVT because they're vertical.
Beautiful. Those are vertical angles right there. That is definitely true. Those two angles are congruent to each other. I'm going to do it just in the order that she said. I think that she said angle SVT. Now, we have to be very careful with this. Be real careful with this because I'm going to be very critical of you at this point. When she said angle SVT, look at where she started. She started between the one that had the 3 and between the one that had the 1. And then she said, okay, well, if I want to talk about these two angles right there, then I have to start at the one between the 3 and the 1. So it'll be RVW is the other one. So angle RVW. When you called this SVT, I knew that this had to be RVW in the exact same way. It could not be called at that point. We don't call it WVR. We don't reverse it at that point because we're saying there is a congruency to these triangles in that way.
If you say if the top triangle didn't exist, couldn't you say
You could call it whatever you want. You're right.
Well,
But we're talking about the way in which these triangles are congruent, so we should be very careful about the way we write things.
the thing that makes them congruent is where they intersect at point V.
Yeah, you're right. You're everything right.
So wouldn't that be okay to say angle WVR is congruent to...
It's not incorrect to say that they are congruent. What's going to make it harder for you is later in this proof. If you don't follow these things, it's going to require more and more steps from you. I'm telling you things that I, from experience, know that it'll get harder in this proof if we don't follow certain orders to things. It means we're going to need more and more steps. Yes, ma'am?
Why didn't we write it as triangle and
Because we don't know anything about the triangles being congruent. We have not proven that the triangles are congruent yet. We've only looked at the angles.
Is there a reason why you underline when we...
I underlined those because that's when I was talking about them. I was
Okay.
showing that those two had to be, that does not need to be underlined. It was just me illustrating what I was talking about there. So, okay. So this is where we are now, is right there. Okay. Look, we've got 3 sides that are congruent and 2 out of 3 angles that are congruent. And don't go to parallel. I know you want to go to parallel. By the way, you can prove that they're parallel at this point, but there's a way easier way that we learned. Yes?
Well, I'm thinking that if they have 2 congruent angles to each other, then the third one has to be congruent.
If only we had something on an earlier slide that had a name for exactly what you're saying.
Does it have to be the third theorem because you did hint, hint, wink, wink?
You're on the right spot. Just tell me what it's called. She's making the statement.
Third angles theorem.
The third angles theorem. She's saying that this one up here, this angle S, has to be congruent to this one because we've already proven that the other 2 are congruent. So angle S is congruent to angle R, and the reason is because of third angles theorem. That's the one we learned today. I've already proven to you that two of the angles match two of the angles. So it is a guarantee that the third angle will match. Now, please understand, here's where people go wrong with this. This only works on triangles. It doesn't work on like 4-sided shapes or 5-sided shapes. Okay, we are almost there. Remember, our job now is that we want to prove that triangle STV is congruent to triangle RWV. Colette.
Would it be like the definition of
Definition of triangle congruency. Because we needed 3 sides and 3 angles to be congruent. Notice in the very first given, they gave us the 3 sides, they gave us one of the angles, and the next 2 steps, we proved the other 2 angles. Therefore, we have all 3 sides, all 3 angles. Those triangles are definitely congruent because of the definition of triangle congruence.
Would we get points off if we didn't put like triangle?
I would mark that entire line off for that, like for sure. Because the definition of congruence is that 2 things are the same shape and same size. With triangle congruence, what you have done is proven to me that 3 sides match 3 sides and 3 angles match 3 angles.